let's do a sample problem where we write either an acid-base reaction with a given chemical. So this is for CHEM101 students or anybody curious for Jacksonville University, and this pertains to Chapter 7. This is one of the problems, 24B, that I did notice some people were missing in the homework, getting incorrect. So let's go ahead and nip this in the bud while we can. So the question from your homework says, write an equation where CH3,2NH acts as a Brønsted-Lowry base. Include the phases. So some people have been getting this wrong because they forget to include the phases. We'll go over that when we do ours. So I always like to just write the balanced reaction first and do the phases last. So we have to identify, what does a Brønsted-Lowry base do? So a Brønsted-Lowry base, so I'll just put B-L base, will accept a proton, an H+. So it will be its compound on the left, and on the right it will have accepted, have taken, have received this H+, this proton, right? So another thing to know about a Brønsted-Lowry base is it will increase the OH minus, which is the hydroxide concentration. So this is an example of a Brønsted-Lowry base. Why is this not an example of an Arrhenius base, by the way? Arrhenius bases must already have the OH in them. An example of an Arrhenius base would be NaOH. Sorry, finish the H there. NaOH, MgOH, 2. These are Arrhenius bases because as soon as they dissolve in water, they just make an OH. No water necessary, right? They don't need to pull a hydrogen off of the, or they don't need to pull a hydrogen off the water. So we're not dealing with the Arrheniuses right now. We're dealing with this Brønsted-Lowry. But all we need to know is that if it told me it's a Brønsted-Lowry base, I know I'm going to take him and I'm going to make him steal a neighboring hydrogen from water. So if I plop him down in water, I'm going to just assume that it's weak, right? Because it's not one of the strong bases. I will not make you memorize that, but just know that if it's not going to be a strong base. So that's what this means, is that it's weak. So if it occasionally steals a hydrogen, what will this H+, what will this compound now look like? So what did you notice I did there? I added a hydrogen to the formula, but I also increased the charge, right? The plus, because it's a +1. And what does H2O look like after you steal one of his hydrogens, one of his H+? He looks like OH minus. Correct? Remember, keep this in mind, H plus OH equals H2O, right? So if you steal the OH, or if you steal a proton from H2O, you're going to be left with this. So make sure that you know that H2O is combined of a proton and a hydroxide. So now let's talk about the states, shall we? Water is always going to be represented as pure, and I do put a little cursive L, and that's just for me, so because if it was just a stick, it would look like a number 1, right? So I always just by habit put a cursive L. And anything that is an acid or a base is going to be aqueous, so AQ. And any ion is going to be aqueous. That's a Q. I put a G. I don't know why. So it's AQ, 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 liquid. So what did we just determine? We said all acids, bases, and ions will be aqueous, and water will be liquid because it's a pure compound, right? It's not ionized, it's a pure compound. So this is how we should go about doing this problem. So I do hope that this helped, working out through it a little bit slowly. And please bring your questions to class, or you could just shoot me an email and let me know if you're struggling with any of the other ones. So good luck with that, guys.